Hi, I'm Scott Swenson. We're at Lynn's Propane Trucks, and we'd like to talk to you today about the Stable Flow Heat Exchanger from APSCO. Now, we've been putting these on a lot of trucks. We put them on just about every tandem axle truck that we build, much like this beautiful one behind me, but we've also been putting them on a lot more of the single axle trucks. So we wanted to take a few minutes today just to go over them, to explain them a little bit to you, why we use them, how they work, the different components of the heat exchanger, and also if you ever were to have a leak, what you would do to isolate it. Why do we use the Stable Flow Heat Exchanger? Well, the Stable Flow Heat Exchanger is designed to maintain the gallons per minute throughout your entire delivery. As soon as you start pumping liquid off the tank, you're dropping the pressure in the tank, causing the propane to boil. So we've all been out in the field delivering to a 500 or 1,000 gallon tank. As that delivery progresses, you'll steadily see the gallons per minute drop. In addition to that, you'll start to hear that pump get louder and louder. Why does it do this? As you're pumping the gallons off the truck, the pressure's dropping in the tank, causing the liquid propane to boil. Now we've all boiled a pot of water on the stove. We've seen those huge vapor bubbles coming up from the bottom as you get a rolling boil. Well, propane works the same way. As you start to pump liquid propane off this truck, it's dropping the pressure inside the tank and the liquid propane wants to boil. As it boils, all those bubbles are going into your pump. Now your pump is designed to pump liquid. So as you start to get that liquid along with all those vapor bubbles into the pump, it becomes much less efficient. So how does the heat exchanger help? It takes liquid propane from the pump, vaporizes it, puts it through the head of the tank, pipe back up to the vapor pressure on the top of the tank. That keeps the pressure up, keeps the liquid propane in the tank from wanting to boil. So the expansion rate for propane is 1 to 270. 1 gallon of liquid to 270 gallons of vapor. So the Stable Flow Heat Exchanger can really very efficiently keep the pressure up in the head of the tank to keep the liquid from boiling. It's taking 1 gallon of propane, turning it into 270 gallons of vapor and putting it back into the head. That keeps the pressure in the tank stable. That keeps your gallons per minute steady through the entire delivery. Whether it's 40 gallons or 800 gallons, the gallons per minute will stay steady throughout the entire delivery. Now when we were on the other side of the truck, you could see that we had a heat exchanger installed. The problem with that is it's kind of in between the frame rails, tucked in there. You really can't see it that well. So we took this heat exchanger off the shelf to use as a prop so that you could see it a little bit better. Now normally this would have a stainless steel cover on it. We took that off as well so that you could get a better view on it. So here we have 2 ports in the front. This port over here would be the liquid propane in. This would be the vapor propane out. This port over here would be the engine coolant in, and the other side would be the engine coolant out, returning to the engine. Now you can see we've got plates stacked up here. So this works very similar to a radiator. So the first plate would be propane, the second engine coolant, third plate propane, fourth plate engine coolant, and so on right through. So they're kind of all stacked together. So as the engine coolant flows through, it's heating the propane and vaporizing it. So the liquid will come from the discharge port at the pump, push the liquid in, it'll circulate through with the heating engine coolant as well, vaporize it, push it out through this port, back in through the head of the tank, into the vapor space on top of the tank to stabilize the liquid propane inside the tank. So as you can see when we were looking at the prop for the heat exchanger, there aren't really a lot of moving parts to break, but you could still have a leak. So what would you want to do if your heat exchanger was leaking? How do you isolate it? First off, you would come over here to the discharge port at the pump. We've got a ball valve here, works just like any other ball valve. When it's in line with a pipe, it's open, so we wouldn't want to put it perpendicular to close that. So now we've shut off the feed, the liquid feed, to the Stable Flow Heat Exchanger. Secondly, we'd want to come over to the head of the tank. So the liquid propane would travel from that ball valve, through that ball valve, to the heat exchanger, be vaporized, and then the vapor would return to the tank here. So we would want to shut this vapor globe valve off as well. So now we've isolated the propane part of the heat exchanger. Now if we're not sure where the leak is, we're going to want to isolate the entire truck, all the piping, the tank, to make sure that everything is sealed off. So let's go to the back of the truck and just go over that real quick. So once we get to the back of the truck, we want to shut the ball valve before the meter. Shut the ball valve after the meter. We've got a vapor return ball valve behind the meter box. We want to shut that as well. We'll want to shut the 90-degree globe valve above the bypass here. And then we also want to make sure that the main valve is shut and that the 1 1/4 internal vapor valve is shut on the truck as well. So we've got both of those shut. Now we've isolated the tank and we've isolated all the segments of the piping. Now there's still two more valves we need to shut to completely isolate the heat exchanger. Let's go take a look at those right now. So the last part of isolating our stable flow heat exchanger would be to shut the ball valves for the engine coolant. So this is the ball valve for the engine coolant coming in. This is the ball valve for the engine coolant going back to the engine. So now we've isolated the entire stable flow system. So remember, we've got the ball valves for the engine coolant are right on the stable flow. The valves for the propane are on the head of the tank and on the discharge port to the pump. So now that we've got everything isolated, our stable flow heat exchanger is isolated, we've isolated sections of the piping in the back of the truck, the main valve, everything's closed up. As soon as it's safe to drive, take it to your nearest qualified propane service station and have the leak repaired. We do have one more item we'd like to address. We recommend isolating the stable flow heat exchanger from June 1st through September 1st. The reason for that is that in the summer months, you're operating at higher pressures. And though it's not common, it is possible that you could have a brief release from the 1/4 inch 450 PSI relief valve on the full circle swivel. Remember, when the temperatures get into the 90s, you could have pressure in your piping upwards of 165, 175 PSI. Add to that 100 PSI from the pump differential pressure, and you're pumping at 265, 275 PSI. When you're that high, it is possible that when you shut the hose end nozzle after delivery, you could have a spike and get a brief release from the 450 PSI relief valve. We see this in the summer months on trucks that aren't running heat exchangers, so it's definitely a possibility. And that's why we recommend isolating it between June 1st and September 1st, and at the very least, during hot spells or heat waves. If you have any questions on the heat exchanger, feel free to give us a call, 800-252-5467. We'll talk to you soon.